So in this video, I'll show you the third scenario where given two lines on the plane. So in this case, two line is given, which is L1 and L2 is on the plane. So equation of a plane determined by two lines, L1 and L2, can be obtained by this against four step. Step number one. So this scenario is slightly easier than the second scenario. So determines the parallel vector ABC from line 1 and line 2. So from line 1 and line 2, we can use the ABC from line 1 and line 2 to find the normal vector. So first, we'll determine the ABC from line 1 and line 2 to determine the normal vector. So we no need to form another vector like the second scenario. We straightforward can use the ABC to find the normal vector. And then find a point x naught, y naught, z naught on the plane from line 1 and line 2. So we can use the x naught, y naught, z naught from line 1 or line 2 as our P naught. So in this case, our third step, P naught is equals to x naught, y naught, or z naught, either from line 1 or we can use line 2. We can use line 1 or line 2, x naught, y naught from line 1 or line 2 as our P naught. So finally, we can use the equal formula for the equation of a plane. So you can see that find the equation of the plane, this example 3, determined by line 1 and line 2. So first, we can use the ABC. Let's say ABC from the line 1 is 4, 1, and here is 0. 4, 1, and, 4, 1, and 0. Why is 0? Because here we doesn't have the variables of t. And then the line 2 for the ABC is 12, 6, and 3. 12, 6, and 3. So we can determine the normal vector from these two lines, from these two vectors. So this is, you can see 410, 12, 6, and 3. So this is the cross product in order to get the normal vector 410, 12, 6, and 3. So from here, we should have our normal vector. Then step 3, we can use x naught, y naught, z naught as our p naught. So this is our p naught. So this is using the first point, 3, 4, and 1. Actually, x naught, y naught, and z naught from line 1 is our p naught. So you can use line 2. You can use -1, 7, and 5. The x naught, y naught, z naught from line 2, either from line 1 or line 2. In this example, line 1 is given. So in this case, 3, 4, and 1 is our P naught. So finally, by using this formula, we can get the equation of the plane. Let's look at this exercise 3. In this case, the Cartesian equation is given, or symmetric equation. In the third example, the parametric equation is given. In this case, the symmetric or Cartesian equation is given. So find an equation of the plane that contain the lines given by this one. Let's say this is L1. Here is L1. Here is our L2. So from the L1 and L2, step 1, determine the ABC from L1 and L2. So ABC in this case, this is actually is over 1. So our ABC in step 1, let's say the ABC from L1 is equals to -2, 1, and 1. Then the ABC from line 2 will be equals to -3, 4, and -1. From these two lines, the ABC from this both line, we can find the normal vector. Let's say normal vector is equals to the cross product of I, J, and K from the line 1 and line 2, which is -2, 1, and 1, -3, 4, and -1. So in this case, our I, So closing the first row and first column, 1, 1, 4, negative 1, minus, don't forget the second is negative, minus j, negative 2 and 1, and then negative 3 and negative 1. And finally, plus k, first column, first row, third column, negative 2, 1, negative 3, and 4. So from here, our I is 1 times negative 1, negative 1, minus 1 times 4, 4, minus j. So this one I have to use a square bracket. Negative 2 times negative 1 is positive 2, minus 1 times negative 3 is negative 3, plus the vector of k. So here again, negative 2 times 4 is negative 8, minus 1 times negative 3, negative 3. From this part, I should have negative 5i, minus, in this case, I can get 5. 5 positive. Here is positive 5 because of here is negative, negative 5j. Finally, here negative 8 plus 3. So this is negative 5k. So again, it's negative 5, correct? So this is positive 5, negative 5, correct? Negative 8 plus 3 is negative 5, negative 5k. Yeah, this is our normal vector. So now we have the normal vector. And then we need the p node. For the p node, you can use the x node, y node, z node from line 1, which is negative 1. This is negative 4. And here is z, where it doesn't have is 0. Or this is from line 1. Again, this is from line 1. X node, y node, and z node from line 1. Line 1. Or you can use the x node, y node, z node from line 2. Negative 2, negative 1, and negative 2. So this is the x node, y node, and z node from line 2. You can use either one. Either the x node, y node, z node from L1, line 1, or x node, y node, z node from L2. In this case, I choose line 1. Why? Because we have 0 here. It's more easier. So continue with the calculation. The formula will be the normal vector, the dot product of normal vector with p minus p naught is equals to 0. Where our normal vector, in this case, I can change to coordinate form, negative 5, negative 5, and negative 5. So negative 5, negative 5, and negative 5 times the dot product with p, x minus x naught. The p naught, the first p is negative 2, the x coordinate. Put a bracket, negative 2, comma. P is the variable y, the second variable is y, minus negative 1. Oh, sorry, I'm using the first line, which is the first p naught. The p naught from L1, which is much easier because we have 0 here. So the first one, let's say p, which is the variable x, minus, here is negative 1. Put a bracket, negative 1, comma, p naught, y, the p is y, minus the p naught, let's say is negative 4. So put a bracket, negative 4. And finally, plus 1, z, minus this one, z, the third coordinate is 0. So minus 0 is equals to 0. So negative 1, negative 4, and 0. So here is negative 5, negative 5, and negative 5. The dot product with x plus 1, y plus 4, and z. So when try to expand, negative 5 times x plus 1, sorry, x plus 1, minus 5 times y plus 4, minus 5 times z is equals to 0. So here we should have negative 5x minus 5 minus 5y minus 20 minus 5z is equals to 0. We try to arrange here. Negative 5x minus 5y minus 5z minus 25 is equals to 0. So in order to simplify and let the variables in positive form, I can divide by negative 5. So negative 5x divided by negative 5 is positive x plus y plus z plus 5 is equals to 0. So here is our equation of the plane. So for the third scenario, where the plane contains two lines, L1 and L2. So we can find the normal vector. First, we find the normal vector by using the ABC from line 1 and line 2. So you can see ABC from line 1 and line 2. Then we can use a point. The P node is the X node, Y node, Z node from line 1 or line 2. In this case, I choose the X node, Y node, Z node from line 1. Why? Because I have the 0 here, which is slightly easier. So you can see Z minus 0. So from this one, the dot product, and we will get the equation of the plane.